Alright, so in this video, we're going to be doing part 3 of our comparison test practice. So we want to use the comparison test to find if the series below is going to converge or if it's going to diverge. And the series we have is the sum from n equals 1 to infinity of the square root of 1 plus n over 2 plus n. Okay, so we got to find a comparison for this. Now, it's going to be fairly simple to at least try to find our first comparison here. We have the square root of 1 plus n over 2 plus n. And we can get rid of these constants here, that 2 plus and the 1 plus. Who needs those? So we get a rad n over n, right? Just eliminating that plus 1, eliminating that plus 2, and you have your comparison. Now next, we need to find a relationship between these two series. Okay, so first off, let's look at our numerator here. We're adding 1 to it, and we're having a square root. So not really going to change too much in the numerator. Here we have 2 plus n, so it's going to already be changing more than if you're adding 1, and you're not taking a square root. So what that means is that the bottom is increasing more than the top. Okay, if the bottom's increasing more than the top, then we know that this is going to be less than rad n over n. And that's a problem. The reason why is because rad n over n is 1 over n to the 1/2. Okay? And, well, we know that this series will diverge. It's a p series where p is less than or equal to 1. So now what we need to do, since we need to use the comparison test, okay, we got to be a little more creative with our comparison. Okay? So we start off with this rad 1 plus n over 2 plus n. Now, a big move that we can probably do right here is to just forget about this numerator as is and compare this to 1 over n. Okay, that might help. So a big move like that could actually maybe tip the scale for this comparison and make this greater than this. Okay, because you're taking something away from the numerator. And that would make it so if you have something, if you take something away from the numerator, this becomes smaller. Okay, so now we made this smaller, so hopefully this is now greater than this. Okay, so let's see. Let's start listing out terms here. We have for our first term here, for our n equals 1 term, we would have rad 2 over 3. Okay, next we would have, well, we're going to plug in n equals 2 now and get a rad 3 over 2 plus 2, which is 4. Next we would have a rad 4, which is 2. Okay, 2 over 5. Next we would have a rad 5 over, this would be now a 6. Okay, and there you go. That's your first couple terms there. Now, with 1 over n, if you start listing out terms, you have 1, comma 1/2, comma 1/3, 1/4, and so on. Now, what I will tell you is that rad 2 over 3 is less than 1, and rad 3 over 4 is less than 1/2. So far, we're still kind of in this zone. But 2/5 is greater than 1/3. Okay? And rad 5 over 6 is going to be, of course, greater than 1/4. And that's just going to go on and on and on. Okay? This is going to be greater than 1 over n. For n is greater than or equal to 3. Okay? But that still means that we're able to use the comparison test here. Okay? Now, when we use our comparison test, we know that the harmonic series, okay, what we just compared to, that diverges. So if this is greater than this, well, then this is going to diverge as well. So now you can say that the series is divergent by the comparison test. So one thing I will tell you about this is not something that you'll really have to do unless it says that you need to use the comparison test for this problem, okay? Because there's other tests that you could use rather than having to go through and kind of make a giant leap of faith that this comparison will work. Okay, now if you do try to make a wild comparison like this where you just forget about the numerator entirely to try to make it so this is going to be bigger than this, then I would try to write out some terms, because maybe you'll see that it doesn't work at first, as it didn't with n equals 1 and n equals 2, but after we got to n equals 3 and so on, it then worked. Okay, so that's why we're able to make this comparison and say that the series is divergent by the comparison test. Okay, so that's going to do it for this video. So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for sequences and series, the explanation video for the comparison test, and the next video in the series. Lastly, if these videos are really helping you and you would like to consider supporting me, I have my Patreon linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.